We will start. Welcome to everybody to this first edition of this workshop, which is focusing on trustworthy software and open source. And we are almost ready to start with our first keynote, Roberto Di Cosmo. But before starting, I will leave the floor to Giancarlo Alonso, who will provide you with a very short introduction about the project that is the context of this workshop.
Yeah, thank you, Elisabetta. So my name is Giancarlo Alonso from Tecnalia, and I want to take the opportunity to very briefly introduce the objectives of the SWForum initiative, which is indeed the initiative under which this workshop is organized. So SWForum is a European initiative funded by the European Commission under the H2020 program that will last until March 2023. And in SWForum, we have three main objectives. First of all, we aim to create a sustainable forum for software researchers and practitioners so that they can share their knowledge, initiatives, and they can foster, let's say, relevant discussions there. And we want that this forum lasts beyond the life cycle of the project. The target stakeholders of this forum would be people coming not only from the research project themselves, but also from other initiatives and on individual basis. Secondly, as second objective, we want to contribute to the research and innovation roadmaps on software technologies, digital infrastructures, and cybersecurity, so that this research roadmap can somehow fit also the European Commission future work programs. And thirdly, as third objective, we also want to assess current and future research projects in their go-to-market activities by a set of, let's say, mechanisms and tools to support their technology and market readiness level. So that would be it. Thank you very much, and I hope you find today's talks interesting and that we have fruitful discussions.
Thank you, Giancarlo. So I'm very happy to leave the floor to Roberto Di Cosmo, who is the director and the founder of Software Heritage. And this initiative aims at building an archive of all open source code that is publicly available. And so Roberto is going to provide his keynotes, and I guess he's going to focus on software heritage and on the role of this infrastructure.
Okay, thanks a lot, Elisabetta, for the introduction. Can you see my slides?
Yes, we can. Thank you.
Everything is fine. Okay, so let me set my timer. Okay, first of all, let me say it's a pleasure to be here with you today to try to share with you, the passion, the vision which is behind this initiative, which is called Name Software Heritage, that I think is just a key building block of something much bigger that we need to try to build together. But let's talk about this a little bit later. A few words about myself, because I'm not the famous guy, so I imagine you want to know from where I'm talking to you. I'm a computer science professor. I was educated in Italy. I then moved to Paris. Now I'm working at IRILL. I spent 30 years in doing research. My original interests were in theoretical computer science, hence my Erdos number, which is 3. But then I moved to programming, software engineering more recently. I spent 20 years in the free and open source software movement as an advocate, as a developer, as a funder, as many different hats. Probably because I do not have enough hair. And then the last 10 years, when you grow older, you assume responsibilities, older or wiser as you want. So I use my energy to actually build and directing structure for the common good. In these slides, you will see some pointers to some key elements that might be of interest for you. Today, I'm a member of the National Committee for Open Science in France, and some 5-6 years ago, actually started Software Heritage at IRILL, which is one of the key elements of our presentation today. Well, a little bit of introduction, as Tony mentioned in his keynote yesterday. Well, of course, we see software has a growing role in the world. There is this famous article by Mark Andreessen, Software is Eating the World. Basically, software companies outperform or buy out traditional companies, and it's still the same if you look at the top entries in the stock exchange worldwide. But then there is a second movement. I mean, open source is actually eating up the software world, because you see more and more and more open source component basically permeating everything which is built today. There is a funny study by Sonatype published some 3-4 years ago, where they actually did massive analysis of a software project hosted in a particular repository of components. And they found out that basically in all new applications, 80 to 90% was just reusing pieces of software that were already there, either libraries or copy paste or whatever. So this is actually coming, it's a reality today. And with this growing use of open source, there are also growing concerns. The point is basically a lot of software systems today are built from pieces and components and can come from so many different places. Of course, a big game in town today is GitHub, but the big game in town 20 years ago was SourceForge, and who knows what will be the big game in town in 20 years. And nonetheless, there are tons of components come from other places. I mean, Bitbucket or GitLab.com, or the zillions of installation of GitLab that you can find around. Then you have distribution, like Debian, package managers like NPM or Maven, etc. So you name it, there are too many. So it's spread around. So it's complicated to know where the software you are using actually coming from. And the big question for you or for anybody who is actually a user or a developer is, where is the software I am building, shipping, using, acquiring, assembling? Okay, where does it come from? The software that has a particular bug or vulnerability, how can I find my way in this gigantic spaghetti dish we are living with? So basically, you know, like in banking, there is this obligation for banks to do KYC, which is know your customer. They are obliged to know their customer. Where is the money coming from? Okay, they are handling. I believe now the time has come for another acronym in our world, which is KYSW. I mean, know your software. Where is the software you are using, shipping, acquiring, composing, integrating, etc., coming from? Be it open or closed, of course, but now with the open source movement, it's so much easier to actually integrate other things in. And that's a big issue, because we do not know how to handle this issue globally. It is not just that. There are so many other issues. Where can I find the software which is relevant for my application? Am I sure that the software I'm using today, the source code of the software, which is available today on GitHub, GitLab, Bitbucket, whatever, will stay there tomorrow in 20 years? Will I be able to access the software if I'm in a country which is disliked by the country where the code hosting platform is working, for example? Is the software I'm getting really the right one, the one I wanted? Has it been tampered with? Is it the same one? Is it in integrity, basically? Traceability. I mean, where are the pieces coming from? Reproducibility. I have a source, I have binaries. Do they match? Can I rebuild everything from scratch? Can I really rebuild everything from scratch? Traceability, safety, security, you name it. I mean, so there are tons of issues coming up. None of these are actually new, okay? But the scale at which we need to cope with this issue has grown a lot over the last decades, and we cannot hide all these issues under the carpet again. So what we need today, this is my strong belief, my intimate belief, is that we need a global coordinated effort that goes beyond our community, actually, even beyond the software community, to build a common, open effort to answer these questions. And for this, one building block is a common, open, shared infrastructure that allows us to track all software. Open source, of course, but not only open source. So this introduction is just to bring you with me to discover the first step we made in this direction by building a common, open, shared infrastructure to track software. This is actually the mission of the Software Heritage Initiative. The Software Heritage was created some 6 years ago with a clear and precise mission, which is to go out, collect, make sure to preserve and make easy to share the source code of all software which is publicly available, which is a broader definition than open source. Of course, one of the reasons is to preserve our past heritage, because in computing, in technology and computer science, we have the privilege that our colleagues in mathematics or physics or other disciplines do not have. We have the privilege to be able to still talk to the people that created all this. And so not losing this heritage is essential, and having a place where to put the original software, landmark legacy software, is important. So of course, this is part of the mission, but it's really just a small part of the mission. The big part of the mission is to create an infrastructure to enable us to better track and understand software and build better software and science for all of society in the future. So if I have to tell you in a nutshell what Software Edge wants to be, it wants to be the reference catalog where you can find and reference all the software source code, no matter where it comes from. You remember the big spaghetti dish or different places where it can come? Well, we want to harvest all of them, put them in a uniform data structure, and make sure you have a general global index of everything which is out there. But having an index or a catalog is not enough. We also want to build an archive, make sure that what is in one particular place available from one particular place today will be available tomorrow, which is not a given. I mean, 6 years ago when we started, it was complicated to explain why we believed a universal archive was needed. After Google Code shut down, GitHub shut down, Bitbucket removed 250,000 projects because they were using the Mercurial version control system. Last summer, don't hold your breath, we managed to save all this because we were already existing, right? But it was a close bet. Now it is clear to everybody that a code hosting platform or a collaborative development platform is not an archive. You need an archive, and so we are building this universal archive. And last but not least, this is a building block for a research infrastructure that allows actually to analyze, explore, study all of the source code of the world. Okay. This is in a nutshell what we want to do. Now, if you want to know how we do this, this is a very complex undertaking. So our philosophy is to just build an infrastructure, which is Software Edge, that only does this. Of course, there are tons of applications in industry, in research, in education, in cultural heritage. We want to enable them all, but we want to develop none. Okay, we just want to keep the infrastructure and having the APIs, the functionality you need to build this kind of application, because it's already very complicated to do that. And you know, the Unix philosophy is do one thing and do it well, and then make sure you interact with other tools. Now, this is not just slideware. If you go to our website, you will see, I mean, we will see it later if you have time. You will see there are over 150 million projects harvested already. These graphs are really very transparent. This is actually how this evolved over the last 6 years. And this boils down to almost 10 billion unique source code files and 2 billion unique commits, because everything is deduplicated. We will come back to that. And the basic principle is that everything we build in this infrastructure is based on open source software. Otherwise, you will not believe that we can build a common, shared, open infrastructure which is designed for the long term. We want to have replication all over the place. We keep facts in provenance, so for every single file which is archived, you can know where we found it, when we found it, how we ingested it. And for each of these, we provide intrinsic identifiers that do not rely on third party and are fundamental for integrity. And finally, as an organization, all this is not a startup, is not designed to be bought up or reused or shut down by somebody else. It is designed from a ground up to be a non-profit, open, multi-stakeholder infrastructure to the service of mankind, okay? in particular of our community, if you want. Now, I imagine you are curious to know how we do this. So let's have a peek under the hood. This is basically built, I mean, actually there are many, many moving parts, but let me give you a view of the most important part. One of these parts is a gigantic crawler that actually goes out there and connects to all the major code hosting platforms, so GitHub, GitLab, Bitbucket, etc., and package managers, NPM, PyPy, whatever, and distribution, Debian, etc. And builds an adapter, a connector there. It is much more complicated than creating a web crawler because unfortunately there is no standard. So if you want to list the content of GitHub, you need to speak the GitHub language. If you want to list the content of GitLab, you need to speak the GitLab language, and they are not the same. So you need adapter for all this. So once you have the list of all these projects, then you find out that this is really a Babel tower, right? So there are projects maintained using Git or Mercurial or Subversion or CVS or RCS or whatever. And maybe there are packages, but packages can be zip files or tar files or Debian package and NPM package. I mean, it's a gigantic mess. So if you want to really keep build a universal archive, you need an extra step, and this is what we do. So we build adapters from every single one of these version control system package formats, etc., to actually load all the information in a simple data structure, simple but not simplistic. Okay, it is a Merkle direct acyclic graph. Merkle graphs are the basic of blockchains, distributed file system, tons of things which are popular today. The original paper by Merkle is 1987, something like this. That seems to confirm that from theoretical computer science to application, you take almost 40 years. But then we are just using this technology. It's kind of standard today. What is not standard is that we are building this Merkle graph at an unprecedented scale. So all of the history of development, so it is not just a source code, but all the history of development, revision, releases, etc., is permanently archived in a unique, gigantic Merkle direct acyclic graph, which is uniform. This contains today over 20 billion nodes and almost 300 billion edges. It is, to my knowledge, to the best of my knowledge, the largest, let's say, quote, social graph you can find out there if you consider that this is a human byproduct, so it is human-made, okay? And due to the technology we are using, I mean, this is less than half a petabyte today, even if it doubles every 20-something months, which is published in other papers that I can point you to. Okay. One of the consequences of the fact that we build this Merkle graph to store everything deduplicated is that we use for every single object in the archive a particular kind of identifier for us in our community. Is easy to say. It is just the equivalent of a commit hash, right? But it is expanded to all levels of the hierarchy, and it is standardized. So this is a typical example of a software edge identifiers. You have a prefix, SWH, which is a register with IANA today. You have a schema version, which is one from a moment, can evolve. Then you have a tag for the object type that can be a content, a directory, a revision, a release, a snapshot, etc. And then you have the hash of the object. For contents, it's just a hash of the file content. For other levels, you need to do the Merkle construction that I will not go through today. We also have other qualifiers that can be attached to these identifiers that can help you focus on particular lines of the object or origins, get information, navigate inside the graph if you want. The good news is that this is kind of an emerging standard. It is part today of the software package data exchange version 2.2 standard published by the Linux Foundation. There is a Wikidata property corresponding to this, and in the slides, since I will not have time to go through this, please do click on these blue links because it will bring you to exactly, or let me try one. Okay. It's easy, take a second. So you see, I click on this link. Behind that link, there is one of these identifiers, and this brings me to a particular section, which is an amusing section of the source code of the Apollo 11 guidance control computer. But you see, it is not these lines only. It is inside the view where you have the branches, the visits, the revision, the name of the file. Everything is done in the right way, and then you can rebuild your permalinks as needed. Okay. And you can do this on any content of the archive. When you visit the content of the archive, you want to recreate a link, you can, for example, for a section, you click on the first line, click on the last line, get a permalink, and you can copy it and reshare it, and it will just, let me do it live, okay. It will bring you to the archive again in the same position. Now, don't be, let me say, this is not as easy as it seems. Of course, you can do something like this on GitHub or GitLab today, but only for content which is on GitHub and only with identifiers specific to GitHub. What you can do on Software Heritage is do this for all the content on Software Heritage, no matter where it comes from. And for everything, doesn't matter if it is maintained under Git or Mercurial or is a package format, whatever. You see, it is an archive, doesn't go away, unlike Bitbucket, GitLab, etc. And it is uniform, do not depend on a particular technology. Okay? That's the key. So this actually, if you think about it, is a really revolutionary infrastructure for open source, but really for software in general. Because you have the graph of software development in a single place, all of the software development in a single global graph. You follow the lines, you can see that this particular file is used in this project, but also in that other one. Because this is the way we build the graph. But it is not any graph, it is a Merkle graph. And this means that actually it is a half of the blockchain for software development. We are not in the blockchain business. I'm not trying to sell you some file coins or source coins, whatever. But keep in mind that for traceability, this is a fundamental property. Then for open science, this is one of the pillars of open science. We need to have a place where we archive and reference the source code associated to our papers in a permanent way, in a persistent way. And putting it on a code hosting platform is not a solution. And using a traditional institutional archive is not a solution either, because they are not designed for source code. But Software Heritage fills this gap. And finally, last but not least, what we provide is really a reference platform for this kind of big code analysis, which are so necessary today with the growth of this availability for source code and open source code all over the planet. Now, this would be the moment where I give you a demo, but this would take me some 5 minutes. I only have 5 minutes left, so I skip it. I will leave you this slide. And again, when you download the slide, everything you see here, all the blue links, are links that you can click on, and they bring you to the relevant things. It's not a live demo, but I mean, it's the best I can do in the time I have. So I leave it for you. And now I would like to zoom on some selected use cases, which I believe can be interesting for this audience. There are use cases right now already for industry. This is just a selection. So for example, one of the obligations when you use open source software is to make sure that if you use it and modify it, or you use it in some of your components that you ship later on, then you are obliged to provide a complete and corresponding source code to anybody who makes a request for it. I mean, this is a nightmare to handle, but using Software Heritage becomes so easy because, for example, this is what Intel does. They archive source code in Software Heritage, and then they distribute only the identifier. And they are sure it is archived, it is exactly the right version. No more processes, cumbersome processes internal to the industries, the responsible people that maintains website, etc. All that nightmare goes away. Then there are more sophisticated use cases, like for example, the Open Invention Network maintains the Linux system definition. And to do so is not easy because they used to maintain it by just pointing to places around the web where the source code was available, but these places are going away. So now what they actually do is they proactively archive source code in Software Heritage. They are a member of a group we created for them. And then they can use these identifiers, the software identifier, to track these contents, verify its integrity, and have a precise definition of what a particular version of the Linux system definition is. But these are just This is just the tip of the iceberg. I mean, there are collaboration ongoing with other companies to build compliance tools, check where the software comes from. We have a collaboration with the US Department of Commerce, I mean, in a larger working group on security issue. And there are applications for supply chain management, for long-term archiving on software when you have obligation in aerospace, for example, keeping something for 20 years or 40 years or something. Add your case here, tons of your cases. Then there is growing adoption in academia. This is another kind of public. I mean, I think it is the other half of the people attending this talk, so I wanted to point out this too. So now we have places where actually researchers can deposit curated metadata and software about your production, and it is archived in SoftwareEdge. Again, click on the links here, you will go to the documentation. The reference archive for mathematical software now links to SoftwareEdge for archival. You have journals which are using now SoftwareEdge as a reference archive for the software artifacts. A growing number of journals, and we are definitely, I mean, this is just a service for free. There is no fee to pay, you just do it. Policy, now SoftwareEdge is part of the National Plan for Open Science in France. There is a policy document I shared. You can find by clicking here the Scholarly Infrastructure for Research Software in the EOSC, European Open Science Cloud. There are guidelines on how to archive in software. I mean, this is moving a lot. If somebody has seen this project 2 years ago, a lot has gone on in the meanwhile, right? Now, let me give you a little bit, in the 2 minutes I have left, my vision about the road ahead. First of all, SoftwareEdge is built for the long term, from the basic moment, from zero. One thing is we wanted to have many entities, organizations sharing this vision. This is the reason why we have an agreement with UNESCO for the long term. And all the organizations, some of which we will recognize here, are supporting this effort. You see the testimonials by clicking this link. And then we need to have diverse sources of funding. So the initial funding was provided by IRILL, who is still a key contributor in this effort. But then you see here all the sponsors that have been coming on board lately. And this ranges from research organizations, ministries, big companies from all over the world, either software developers or users. Then you have large universities, many other entities. And of course, there is a lot of space. We need much more people to move forward, but you see at least this way that this is just an open project. Okay? Actually, it is not even a project, it is an initiative. It doesn't have an end date, right? So, but it is not enough. We are not just diversifying the partnership and source of funding and source of support for this initiative. We are also creating a mirror network to make sure that the survival of this initiative in the long term does not depend on a single institution. And so I'm very happy to say that we have signed an agreement with the INEA, which is a very big research organization in Italy, to actually build the first institutional mirror in Italy. We have also another agreement in Sweden with a private company, and we look forward to have more mirrors around the world. A mirror is a full copy of SoftwareEdge managed by another organization that has an agreement with us, so in such a way that they reduce the risk of incident. But it is not enough. It is even more. What I believe is that SoftwareEdge provides for us a rally flag for a much bigger vision. If you look at what we are going through today with this gigantic disaster, which is epidemics, the key solution to handle this crisis situation is to actually have open access and free sharing of knowledge. There are so many examples. It would take a day to give you an example of this, but just, I'm sure you know what I'm talking about. We in the software community, we have the responsibility to bring together academia, industry, governments, community to build a global infrastructure, open, shared, reference infrastructure for building better and open software for society as a whole. Here, SoftwareEdge is a first brick. It is vendor neutral, it is open source, it is worldwide, it is long term, it is born in the EU with our values, and it will enable a lot of immediately valuable things for industry, academia, and governments that can trigger then the addition to the big and grand vision. But this is just the first brick, right? So we need help from all of you to create this brick and to build on top of it, because we need a bigger undertaking. We need education, we need research, we need sharing broader, in a broader way, across disciplines, all the issues related to software development. So, well, okay, I'm already slightly over time, so let me conclude. I hope to have you convinced that we have an opportunity now to work and build something like a library of Alexandria code on one side, a server for software on the other side, and a larger global vision we can all share. I do hope. So my point is, please, let's try to work together to make this vision a reality. If you want to know more, please contact me. And if you want to know more about the initiative, here are some pointers to publication. And I will stop here. So if there are any questions, I will be more than happy to take them.
Thank you very much, Roberto. Is there any question for Roberto? I think we have not too much time, but 1 or 2 minutes for some questions.
I put my hand up.
Yes.
Hi. Yes. Hi, Roberto. Thank you very much. Thank you very much for your presentation. It was very interesting. You mentioned, of course, harvesting code. What's the process that you actually go through to quality assure the code? Because, of course, you know, there are vast amounts of software out there that maybe don't even work, you know, from that point of view.
Absolutely.
So how do we actually have a robust quality assurance mechanism in place? And I would say with I have a little hat that I'll put on here, is that I'm actually the editor-in-chief of a software journal. So I'm very interested in, particularly in this quality angle.
That's a very important point. So thanks, David, for asking the question. Again, I didn't have time to go through all the principles there before. So the key question you're asking is, what is the filtering we make on what we harvest? Do we filter anything? Well, you will be surprised, we do not filter anything at all. So the point is that we want to get everything, because you have to make a choice. Should I filter and only keep what is valuable and taking the risk of losing something valuable to make sure I get rid of all the garbage? Or should I make sure I don't lose anything valuable by keeping everything, including all the garbage, and then building a quality level on top of it? So we have taken the second way, so we keep everything. I have a short anecdote. If you remember PHP 1995, this message by Rasmus Lerdorfer in the Usenet saying, hey, I'm fed up of building HTML pages by hand. Here is a personal home page tool set, which is a short hack you can use. You would have thrown it in the bin, in the trash basket immediately. And today it is basically used all over the planet. So we do not want to lose anything. But when you talk about academia or industry or software, what is extremely important is the metadata. It gives you qualification, and the portals that tells you inside this gigantic archive that has everything, what is the part you are interested in. And this is the way we work with the portals like this National Open Access Portal or with the journals. So they have a special deposit interface. So they deposit the object in there, they add their metadata, and then we have metadata that say, hey, this piece of software is actually associated to this article right there. And the quality comes from our community, from the publishing community, not from the archive itself. Then on top of the archive, what we can provide you, and we provide to other people, are tons of interesting tools, like, for example, something that we can tell you if an author submits a new piece of software, what part of this software is original and what part is just copy-paste or something that is already there. And if it is already there, where is it? You know, these kind of provenance queries are something we are developing and that are extremely useful then to help people like reviewers and referees to do a better job. Today is not so easy when you look over software to understand whether it is of quality or not, unless you are in very specific cases. If you're interested, you should look at this IRILL journal, which is in image processing. They do an incredible job, but it's a very specific, because it is a journal that publishes algorithm about image processing. So the software must be associated, and the reviewers look at the paper and the software and make sure it actually works well. You cannot ask this for every other discipline, right? But this is the idea you could tend to. Okay.
We've taken a route like that in a general way.
Ah, fantastic. In that case, please, come have a talk offline, and let's see how we can work together.
So I see that there is also Tom wishing to ask a question, and then we need to, Tony, we need to then move on. But please, Tony, go ahead.
Oh, good. Thank you. Enjoyed your talk, Roberto. One of the questions that I have has to do with media. There's a lot of old software on zip drives and magnetic tape and 8-inch floppy disks and other kinds of antiquated things. What are you able to do about retrieving source code from all of these ancient media sources?
That's also another very important question, Tony. Thanks a lot for asking it. Actually, we have worked a year and a half ago with UNESCO and with my home university in Italy, which is University of Pisa, to come up with what is now known as the Software Heritage Acquisition Protocol that actually describe the path to be taken, to steps to be taken to actually rescue, curate, archive, and reference properly the landmark legacy source code. And of course, there is a part where we as software developers are not necessarily the best one to do it. I mean, they're typically recovering from particular cartridges, I mean, from the physical media to the digital form. And there we rely on passionate people that work in museums for doing this. Like, for example, the experiment we did in Pisa was together with the Museum of Computing in Pisa, where they actually could recover even printouts of the first programs in Fortran written on the first Italian computer in the 60s or something like this. So that is a part that is not what we do as software engineers, but we help create the right process and try to collaborate with these people. Like, for example, you know, the Computer History Museum, this kind of, they are beautiful guys who are able to do that. And we come in only later on. So we provide the place where you can store the software in the proper way with the proper history. Once you have done this recovery effort, which we do not have the resources to provide ourselves.
Do you point people to the right sources for a particular kind of medium?
Not yet. There is a mailing list. I mean, this is not necessarily yet public. There is a mailing list that tries to bring together museums in different places. This is run with people at UNESCO, etc. That should do this, but we do not do this yet. So we just say, get in touch with your preferred museum.
Right. Thank you.
You're welcome. Thanks a lot.
Thank you very much, Roberto. So we are going to have some more time for the discussion later on at the end of our presentation. For the moment, this is a virtual applause. Unfortunately, we cannot do it in presence, but we all appreciated your talk. Thank you very much. So we now move to the next speaker, who is Frank. Yes, I see you, Frank. So Frank Karlitschek, I hope I pronounce it well, probably not, sorry. In this case, Frank is the founder of and also CEO of Nextcloud. And it is, of course, also focusing on open source. And so he's going to present his viewpoint on the importance of open source software for digital sovereignty, research, and Europe overall. So please, Frank, the floor is yours. Thank you.
Thanks a lot. Thanks a lot for having me. Let me see if I can share my screen. Yes, this should work. 1 second. Okay. Can you see my first slide?
Yes.
Excellent, excellent. I think it's the first, the most said sentence of 2020. Like, can you see my slides? So I have to say it too. So thanks a lot for having me to talk about the importance of open source software for digital sovereignty and strategically for Europe. As already mentioned, my name is Frank Karlitschek. I'm born in Reutlingen in Germany. I'm an open source contributor and board member of KDE for many, many years. So over 20 years, I'm involved in open source and free software. Founded a number of initiatives and projects over the years. I'm an invited expert for the W3C. That's the consortium based at MIT in Boston that works on internet standards. I'm a fellow of Open Forum Europe, which is a lobby organization on the European level for open source and open standards. I founded OwnCloud and I founded Nextcloud, a successor, and I'm also an advisor to the United Nations regarding the open source strategy. So I want to talk a little bit about the cloud as one of the biggest IT trends of the last years, then about what digital sovereignty is, Gaia X, which is an interesting project, and then hopefully at the end we have time for questions. So as you know, the cloud is one of the biggest trends in computing the last 10 years, 15 years, maybe 20 years. It basically means that infrastructure is outsourced to some other entity. This can be networking or storage or compute or the application itself or the data itself or a combination of all of that. But of course, it also the situation is also that a lot of companies and organizations are also very skeptical about the cloud, what it actually means for privacy and security and digital sovereignty and so on. So I looked up some reports, and there are lots of them on the internet, that it seems that one of the biggest concerns that people have, and also companies, of course, universities, everybody, regarding cloud computing is security. So a lot of people are skeptical about the security, what it means if you move into the cloud, and what effect does it has. There's also, like, of course, more studies here. For example, it also talks about the effect of the vendor login, that once you move to some cloud provider, that you can't move away to anything else anymore. Here's some more information that again, security and compliance is a concern. Compliance is, of course, also very interesting. How does it work with GDPR requirements in Europe? And if the cloud provider is from somewhere else, or the data is hosted somewhere else, the application is hosted somewhere else, how is it with networking? How is the security, compliance, everything related? So these are long-term complaints already. Some of the studies are already a few years old, but they're still totally valid. But of course, lately the discussion heated up even more. For example, as you all know, the Safe Harbor Agreement, Privacy Shield, was killed in Europe last summer for the second time. This was an agreement which basically said that no worries, everybody who has to follow GDPR can also store their data in the US, and we just assume that the US is also respecting the GDPR. Obviously they're not. And the highest European court has now ruled that this agreement is no longer valid, which means storing data outside Europe de facto is a GDPR violation. And this was a big shock for a lot of people last summer. Then the question was, okay, what really happens now? And actually last December, for the first time, an organization actually had to pay fines, penalties for doing that. So this is a Swedish university which stored personal data of users at box.com, a US-based cloud service, and they had to pay like 50,000 euros of penalty for doing that. And of course, this will now happen more and more. So this is an interesting situation that we are at the moment. And this leads to a political discussion around digital sovereignty. So what does it really mean for an individual, for a company, for a university, for a state to have digital sovereignty? So how much do we depend on basically services and software and infrastructure coming from somewhere else? There's an official definition of digital sovereignty. I looked this up lately. Definition is digital sovereignty or cyber sovereignty is the degree of control an individual, organization, or government has over the data that generate and work with at local or online platforms. Right? So basically, how much control do we have over our data, our software, our infrastructure, our digital lives? Obviously, if we don't have a lot of control over that, then this comes with a number of strategic risks. I collected some of them. The first is, that's the obvious one, the strategic risk is that we lose control over data represents a strategic risk for our society. Individuals, businesses, and governments are surveilled, and their data is monetized by foreign corporations. So that's basically the danger, that our data is stored somewhere else, and we don't have control over that. And it's accessed and used by other organizations, companies, even to the extent that they might monetize it with, for example, advertising. Right? We know that that's a common thing with Google, because Google's business model is advertising. And if you give them any data, they obviously do some data mining there and analyzing the data and do some profiling and selling you advertising. So this is the business model, which is a good question if we want that or not. The second strategic risk is obviously when debates that are important for our societies take place on platforms owned by corporations and hosted in countries with a vested interest. How can we trust the results? This is something that, a few years ago, this problem was not really seen as problematic. But nowadays, with some elections in some countries, you can actually see that elections and overall decisions and the sovereignty of a state can be threatened if the whole discourse, if the whole conversation, if the whole political process is happening on a platform that can be manipulated by someone else. So that's obviously a risk of if you don't have digital sovereignty. The next one, that's a bit of an economic point, where nearly all commerce flows through a few selected platforms. These platforms control the price and capture most value. That's something that you can really see a lot, especially at the moment in Germany, where I live, but I think it's the case for most of Europe, that with our horrible COVID-19 crisis, we are all in lockdowns a lot, so we stay at home. So we move more and more of our commerce to buy like food and other things to online platforms. And the biggest one is of course Amazon. By basically half of Europe or more of that buying everything from Amazon, we basically killing our own local shops and infrastructure and supply chains. That's obviously a huge risk. The next one, and the last one, this is about innovation. So if we in Europe want to keep on innovating and building interesting things, for example, around machine learning, self-driving cars, big data, artificial intelligence, all kinds of things, then it is a problem if the only way we can do that is use services and innovations and software and platforms that are running somewhere else. Because then basically the innovation process is not open. It's not fully, you can really invent everything you want. You basically can only invent what is supported by the APIs of the platforms that you use. So if there's no way that we can do our own machine learning, the only way to do machine learning is to become a customer of some machine learning service from some big cloud provider, then that's of course a problem. So all these risks are nowadays seen by the politicians. So there are a lot of politicians in all over Europe who see this now as a threat. So this is something that was not taken serious like 10 years ago or 5 years ago. For the last few years, there's a lot of discussions. I'm personally involved in lots of conversations all over Europe about that topic. That's something that we have to look into. This is, of course, a bit funny, a bit ironic, this discussion, because other people saw this problem a long time ago already. This is some of you might know him. It's Richard Stallman, the founder of the GNU project and the GPL software, basically the founder of the free software and open source movement. And he already in the early 80s came up with 4 freedoms. This is something he postulated, that this is something that everybody should have regarding the software. These are basically the principles of open source and free software. The first one is the freedom to run the program as you wish for any purpose, but there should be no restrictions. Everybody should be able to use the software for everything they want. The second one is the freedom to study how the program works and change it. So does your computer, does your computing as you wish. Access the source code is a precondition to that, right? So you have to be able to access the source code of an application to really study it, to learn how it works, and to build innovation on top of it. The third is freedom to redistribute copies so you can help your neighbors. That's of course a bit funny, right? I mean, this comes from the 80s. The internet was not really developed at the time. So basically sharing software with others was actually giving floppy disks to your neighbors. So this was how it works in the 80s. But the point is, of course, that you should be able to share software with others. The same way you also should be able to share knowledge and data with others because it helps everybody. And the fourth one is the freedom to distribute copies of your modified version. So that's of course the key. So the idea is that you get some innovation from somewhere and they can innovate on top of it. And then the result of it should also be then shared with everybody. Right? This is something that's often called standing on the shoulders of giants. Right? So it's not really possible to invent everything from scratch, right? The world is too complicated for that. So it's important that we have like building blocks done by other people, and we can stand on top of these building blocks and innovate. And this is how we can move forward. Okay, so as you have noticed, these 4 freedoms from Richard Stallman's are all about software, open source and free software. That's of course simple because at the time there was no internet as it is today. There was no cloud as it is today. It was basically you have a computer which is typically was sitting on your desk, and then on the computer you run open source and free software with the 4 freedoms as I just described. And this basically means that you have digital sovereignty, right? So you have complete independence. You have the hardware, you have the software. You can do everything with both sides. And then you have the full freedom. Of course, the question is if this is still the case today, or if there's an ingredient missing. And obviously, the world is getting a little bit more complicated. For example, there is the challenge with data. So data is also something that needs to be controlled for digital sovereignty. At the old times, this was no problem because the data was obviously on my local hard disk. Right? And if I own the software and I control, if I own the hardware and I control the software, then obviously my data is also safe. But nowadays the data can be somewhere else, can be hosted by some cloud provider somewhere on the internet. And that's something that's needed for digital sovereignty. Data can mean lots of different things. I want to cover like 2 different types now. One is personal data. So my personal pictures, emails, chat messages, documents. This is something where I created a few years ago together with some other people from other projects, something called a user data manifesto. So the idea is that there should be basic rights defined to control your data, who can access it, where it's stored, freedom to move it to some other platform. There should be some basic rights. I'm really happy that this was really picked up by the GDPR, which came a few years later. And I think the GDPR is not perfect, but it guarantees some basic rights around personal data. Another type of data that's very important is, of course, data that's used for machine learning. Let me give you an example. Let's say you want to build innovation on top of self-driving cars. And of course, there are some companies like Tesla, which are very innovative in this area. Okay, so how would you do that? Let's say Tesla would open source all their software tomorrow, which they don't, unfortunately, but let's assume they open source their software tomorrow. Then the classic free software community would be really happy because, well, everything is open source, nice. The problem is, if you have the hardware, which would be the car, which you can buy, and then the software, and you put the software on the car, then this is not enough to have a self-driving car, because you also need the learning data. You need to have all the petabytes of learning data to actually build a self-driving car to train the neural network. So data is definitely something that also needs to come into consideration regarding digital sovereignty. Okay, so let's go back to this equation here. Let's say you control the hardware, you have the software. Let's say you control your data, it might be personal data or like machine learning data. But then the question is this enough? Do I then finally have digital sovereignty? But I think there's another component that needs to be taken into consideration, and that's the cloud. So the cloud, as I mentioned, one of the biggest trends of the last few years. So what is this cloud thing? What is the cloud? And I actually did some research a few years ago where I thought, why is it called the cloud? Where does it come from? And I think I found an answer which goes back to the 90s, and it goes back to PowerPoint. And we all, maybe the older one of us, including me, we all saw this kind of diagrams in the 90s. So this is something that described, like in this case, the local infrastructure, let's say in an office, where you have like some video conferencing, you have an ISDN card, you have a fax machine, you have a phone, you have all kinds of things. And they are connected with this red network, basically, this red line in the middle. But on the left-hand side, you see the cloud. And they see there is something else. And what is meant here, people will use this PowerPoint clipboard, the cloud here, and they put it there. And what it was meant with the cloud was like, okay, there is more. The red network is connected to something else. It's connected to my systems, but I don't really know what it is. It is somewhere else. It's not my business. It's invisible. There are definitely like hard disk and cable and switches somewhere there, but I don't know. It's other people's business somehow. This was meant, this is the original of the term cloud. Here's another diagram which describes some database servers and switches and other components. And again, on top is the cloud. This is something where, like, I don't know, some kind of other infrastructure is, but I don't really know what it is because it is done by other people. But it's connected and it's obviously important. Of course, nowadays, it looks a little bit more like that. So the cloud is huge and the local infrastructure is tiny, okay? Because what we have now in our hands is with our smartphones or in our offices and in other places, they are just like ways to access the cloud. And our smartphone is useless without an internet connection to the cloud. And the same with our computers and our telephones and lots of other things. So the cloud becomes like huge and everything. Okay, but where is this thing? What is this cloud? I mean, cloudy, great, but what does it really is? There's this great campaign from the Free Software Foundation Europe from a few years ago, which says there is no cloud, it's just someone else's computer. Yeah, that's of course totally true. It is not this like undefined thing. No, these are actually computers owned by, I don't know, Amazon or Google or Microsoft and others. So that's the cloud. Then the question is, where is the cloud? It's definitely not in the sky, right? It must be somewhere else. And I did some research to look where the cloud is actually storing the data. And yeah, it was actually quite simple to find the cloud because that's where the cloud is. It's basically in Silicon Valley and a little bit north of it, Seattle, where Amazon and Microsoft is. Okay, so now I described the problem enough of digital sovereignty. So the question is now, of course, what can we do? So what can we do to protect the freedom and the privacy of home users, of governments in Europe, of companies in Europe, of free research and everybody else? I think I collected a few mandatory pieces that we all need to guarantee this digital sovereignty and yeah, to have a working future in IT. The first is, I think we need a rich and decentralized infrastructure. I think we want to have lots of service providers all over the world, really distributed. I don't have a problem with Amazon or Google creating like great cloud services. My main problem is that there are only 3 or 4 of them. Right? There should be like 10,000 of cloud providers all over the world. And then basically outsourcing the software and data to someone else is fine, as long as you have the choice. And I'm really happy that Europe sees this challenge. And there's, of course, this Gaia X project. Most of you might have heard it. It's an initiative originally coming from Germany and France, but now expanding to lots of other countries all over Europe. The idea is that in Europe, we should have an alternative to these big cloud services from the US and China. But the idea is not to build this in a centralized monolithic way. The idea is to do this as a federated, decentralized way by connecting all the smaller cloud services in Europe together into one virtual big cloud. And this is, of course, done with open standards and free software, open source. So I think that's a good step. I'm not sure if this succeed, by the way, but the direction is definitely very good. The second is, I really think that we should have, for all applications and all data, should have the choice between on-premise and off-premise. So on-premise means running on my own servers that I have somewhere, that I trust, that I control, or I decide to outsource it to a cloud provider. But both options should always be possible, right? But if you look at modern software, Microsoft 365 or Google Workspace, you can't run it on your own, right? You can't run it locally. It only runs in the cloud. And that's, of course, has to do with the business model of these companies. The third is open source software. So all the important building pieces of this software stack needs to be open source. And now I come a bit to the advertising block. Of course, that's what we try to do with Nextcloud, right? With Nextcloud, we are building this open source free software alternative to Office 365, Microsoft 365, Google Workspace, Dropbox, and so on, with file syncing, chatting, video conferencing, groupware, Office, and so on. And there is more of that needed. I think Europe really should invest into the local open source economy and market, because that's something that can give people here freedom, but also the opportunity to innovate on top of it, as I said before. For that, an open source business model is, of course, needed. And I'm running a bit out of time, so I don't have time to go into too much detail. But I really strongly recommend to only use one working business model for open source here. And that's basically the only business model that really created like the relevant big players. That's used by Red Hat, it's used by SUSE, used by MariaDB, by many others, and Nextcloud too. And this means selling enterprise subscriptions. So the code is completely free, the code is completely available to everybody, but a company selling the subscriptions to big organizations to help them with scalability and security and customization and so on. And this also doesn't require code ownership, by the way, and this doesn't come with vendor login. So I think this is a very solid, open, and fair, it's about fairness, business model. Another thing that's really important is that we have many implementations. It's really bad if there's only one software that we rely on. We should have open standards, I'll come to that in a second, so that there are different implementations for different pieces, but then together, we have then this rich ecosystem, and this then solves our problem with digital sovereignty and surveillance capitalism, of course, too. Open standards, as just mentioned, I think there should be established rules and laws in Europe that make open standards mandatory for cloud services, for social network, for productivity software, and so on. And if you look at like the economy, if you look at cars, right, there is an open standard called roads, right? Roads are open and you can drive on a road, doesn't matter which car manufacturer you have, right? And this creates like this equal playing field where everybody can build cars, they can compete with each other, and they can all drive on the same roads. But if like roads become like proprietary and basically there are roads for one brand and roads for another brand of cars, then you can't invent a new car because you can't build like complete new roads. And this is then no longer an open market and no longer has the benefit that's needed. So open standards for everything guarantees good competition. And the last but not least, I think there should be laws how data should be handled. Privacy rights, data portability, and so on. The GDPR is a good step forward. I think there's the opportunity to do more. I think Europe really needs to protect their interests, and there should be like legislation to make sure that we not end up as just customers of some other continents. Okay, and I'm running out of time, so I'm already at a summary. I think digital sovereignty is mandatory for free and open society. There is, like 20 years ago, a computer and the internet and IT, this was optional, right? We are living in a free society, and then, well, we used like IT a little bit in between. Who cares? Nowadays, it's clear that IT and communication is everything, right? We do everything there. This is like how we communicate, how we do productive. Nowadays, we're doing COVID-19, how we do our video calls. This is the same as electricity and water and roads and other public infrastructure. So this is very important. So we need to protect our digital sovereignty unless we will lose our open societies. This means that we can and have to shape the future of IT. So we have to get into an active role and really shape our future of the digital world here. We can't just like sit back and say, yeah, everything happens somehow. It's just, let's see how it goes. I think we in Europe need to take an active role here. The internet and the cloud is built by engineers, which means we can change it. That's something that it's a surprise to me sometimes. A lot of people don't really see the difference. There is the nature, right? There is like the sky, there's the moon, there are trees, there is the ocean and lots of other things. They are what they are, right? But there's the internet and the cloud and smartphones and social networking and cloud computing and so on. And they are not nature, right? They are like done by people like us, and we can also change it. If we don't like how social networking works, if you think that it's toxic or harmful for democracy sometimes, then we can change it, and we should change it. And we have the opportunity, especially in Europe. And last but not least, I think free software and open source is the absolute key for digital sovereignty, because it guarantees privacy and security, innovation, and just overall lots of freedom. Okay. Thanks a lot. I'm sorry for speeding up a bit. I'm trying to catch up with the time. I hope there's still an opportunity for some questions.
Yeah, we do have opportunities for some questions. I think David has been writing various questions on the chat, so I guess he wants to ask something.
Yeah, absolutely. So I'm sorry, Frank. I must admit, I disagree with you on quite a lot of your points. You know, the reality is that, you know, you talk about, you know, surveillance capitalism and all this sort of thing, and the mega cloud providers. The reason they're there is because they build a better product than other people. You know, some of the largest customers of Amazon, for example, in Europe, are Telefonica, because they don't want to use their own cloud product because it's not reliable enough. I think, you know, we've got to get over this, you know, sort of, oh, well, we mustn't engage with these other providers. You know, these people are multinationals employing huge numbers of people across the continent. I was sort of hoping when you put up the map of where the cloud was, you were going to show everywhere, because the cloud is everywhere. So
no, it's not. I don't think it is. It's owned by like 5 big companies, all in the US.
There are thousands of providers. You know, there are thousands.
Yeah, I know. And we are at Nextcloud, we try to work with lots of them, and we have like 100 providers that we work with, but they're all tiny.
Well, but they get big. You know, all of these providers, apart, you know, all of the big providers started small. So from that point of view, you know, they grow by doing a good product. I would say that, you know, when I look at things like SAP and things like that, I'd say equally, well, that worries me, because that's the financial management of loads of companies, and that's in Germany. I don't think I'm not sure I think we sort of need to get over that to think about the quality of the service being the mechanism by which people decide to use these externally provided things.
Don't you think there are like antitrust questions here? I mean, for example, GDPR requires data portability. So the idea of the GDPR is that you can export your data from one provider and import it into another, which is a good thing. Unfortunately, that's not possible. I'm trying to export your data from Microsoft or Google or Box. It's just not possible. So it's really hard for someone else to compete.
So then somebody should set up, and I must admit, so I'm a user of Nextcloud. We do run Nextcloud, and because it's a good product. From our point of view, the fact that GDPR to me actually is a boon for the big companies, because it's actually very difficult to be compliant. It's an incredibly complex thing, and so from that point of view, I think we've slightly owned gold in a number of areas that, by doing things in a way, by trying to do things through legislation, is maybe, it makes things much more difficult than it probably possibly needs to be. And I think, if we look at the success of domain-specific cloud providers, of which Europe is a leader in, which are the slightly smaller step down, that's the way that we can go forward.
Yeah, and just to be clear, I don't disagree with you that at the end, it's also the quality of the product. I totally agree. And there's a lot of bad products out there in all areas. There's a lot of bad software out there. And definitely the software of some of the big cloud providers in the US is good. I totally agree with that. Obviously, you want to compete with them and you want to have a good offering. Otherwise, and if you have a bad offering, you can't fix this with legislation. I mean, that would be stupid. I totally agree with you. But even if you have a good product, and I think there are some good cloud providers, I mean, we're working with like OVH at the moment, or we're working with Ionos, we are working with German Telekom and some others. They have compelling products, but they really have trouble like growing to becoming a real hyperscaler. And there are reasons for that. And that's something that I think we should look into.
I think federation is a way forward. You mentioned open standards, and I think that's a really important way.
Yes, I agree.
Because if you federated all of those smaller providers in a standards manner,
yes,
then that would certainly be a mechanism by which you could see growth. But that requires people to collaborate, which is always fun.
Okay.
Sorry, I
stopped you, but
no, that's excellent. It was fun. Yeah, we
are really running out of time. It was very interesting. There is a question by Mark, but I'm not sure we have enough time. Mark, if you feel it's very, very quick, then ask.
Just let me make a comment. From the standpoint of a SME, one of the things that I think is really different in Europe is there is the possibility in the North American environment to do a very quick scale up. The venture capital community is very well organized. In fact, even European companies get US venture capital quite quickly. One of the things that we're doing, and I'm going to put a plug in for the European Cybersecurity Organization, is that we have been putting venture capitalists together with SMEs. So one of the issues in Europe is the defragmentation of the environment with respect to startups. And I also support what David said about this issue of federated organizations doing this, because I think we need to find ways of being able to be competitive in an environment where a North American company comes up with a crazy good idea and they get 10 venture capitalists running after them, throwing money at them. We sit in Switzerland or in Europe somewhere, we have a great idea, and the venture capitalists aren't even beating on our door until we're at the point of breaking even with revenue and profitability. So it's a very different environment, and I think that's something which also affects the situation quite dramatically. least.
I agree. I mean, I had like the former company before I founded in the US. I lived in Boston for 3 years, and we were like funded by 2 big venture capital companies in the US. So I know a little bit about that, and I totally agree with you. It's a totally different environment, and yeah, maybe I should add a slide about that. I agree. There's good funding for companies is something that also is important for Europe. I totally agree.
Okay, so thank you very much, Frank, for this talk. And we will have hopefully some time at the end of the other speeches for wrapping up and maybe have some other questions. Now we move to the presentation of papers. I think the first speaker is Rafaila, that I see connected. And while she gets ready, John can say something very, very quickly about Software Forum again.
Yes, thanks very much, Elizabeth. I want to repeat something I said yesterday, but there may be some new people here today. One of the key activities of SWForum.eu is to create an online forum which is directed specifically at European software researchers to discuss issues and trends and concerns in software technologies, digital infrastructures, and cybersecurity, like you see here. So here it is. I'm showing it to you now. At least I hope you can see it, and it's coming on live right now in these days. As you can see, it's a fully fledged professional platform for discussion groups, creating user profiles, following discussion threads, and upvoting likes and dislikes. But what's unique about it is that it's for us in the European software community. And by the way, it's also a unique opportunity for us to make our voices heard by the European policymakers, by developing recommendations regarding future directions for software technologies in Europe. So please join. The link will be up here on the right hand corner of the forum page of our website. You'll see that you can sign up at both individual and organizational levels. So please do so. And one last point, I'm going to put on the chat now a link to a questionnaire that we have developed in order to check the state of software in the EU. So please help us by contributing and filling out this questionnaire. Thanks.
Thank you, John. So Rafaila, the floor is yours. If you are ready. The paper is titled, well, you have the title on the slides, so please feel free to start.
Hello, everyone. My name is Rafaila. I'm an undergraduate researcher, and together with my professor Diomidis Spinellis, we are going to present a dataset of open source safety critical software. So our motivation were that open source, as aforementioned, that allows the study of safety critical applications in terms of code, development processes, and components. And such software should be first established. So starting with our methodology of finding that kind of projects, we followed the guidelines presented by Kitchenham and Charter. We searched the electronic sources of Google, GitHub tags, and GitLab tags. And we used these queries. The first one was used in all during all the search strategy, and it ensures us that it is an open source system. The second one concerned the domains that it is safety critical. The third one, it was regarding the applications. We parsed all the conferences available for avionics, automotive, and we gathered some keywords where that kind of software can be used. Here there is an example of 4 the keywords for automotive specifically. And the last one is the standards that are generally used for avionics, automotive, and medicine as well. The inclusion and exclusion criteria were firstly about the repository characteristics. We wanted to have projects have a GitHub repository, Git repository generally. We excluded all the inactive projects, more specifically all those that were inactive the last 8 months. And regarding the popularity, we put as a threshold the 70 stars. And the second one, we examined all the remaining projects in terms of their role, their safety critical role. For example, we found a lot of projects in medicine, but they were used only for a medical imaginary viewer, for example, X-ray analysis and stuff. So here there is the final selection. We found 42 projects. You can find it in the paper as well. We saw that the most famous domain was automotive with 12 projects, and it is followed by avionics and infrastructure. The most popular languages we found were C++, C, Python, and Unix. We conclude that there is no widespread industrial practice because, as I also aforementioned, some leaders in the fields, for example, avionics, they keep their repositories private. And we also noticed that there is lack of activity and popularity because they start the project and then maybe if there is it is not very likable by communities, they just archived it. This work will be used for analyzing the quality of such projects. We use the classification made by Raham and Devan Bu, and we will split the metrics in terms of process and code metrics. For process metrics, we will use especially GitHub API and some other tools like Reaper. For measuring the community and developer metrics. And for code metrics, we will use for static analysis the Secumetric tool. And then the idea is to compare the safety critical projects and their results of our previous analysis with some other famous open source projects which have a quite big Reaper bad score. Reaper, in case that you do not know, it is a tool, an open source tool that assesses every open source project. That was our presentation. I hope that we do have time for questions.
Thank you very much. Is there a question for Rafaila? I have a question. I was wondering, so you mentioned that you selected the 42 projects. I was wondering, how can you recognize among the whole set of open source projects those that have that you can consider safety critical, or so how do you identify them among the others?
As I mentioned before, we use some keywords here, and we used all that keywords in tags, in GitHub tags, in GitLab tags, in Google, and we read the full documentation of the project. And yes. For example, there were a lot of projects that mentioned that, for example, for automotive, we used this module for braking systems. So we see that, okay, this is a safety critical application. Some other, for example, especially a good example was that medical imaginary viewer, where only the projects were only developed for analyzing the X-rays. So, and using machine learning and very smart techniques, they analyzing whether, for example, a bone is broken or not. That kind of project were excluded because it is not a safety critical application. Safety critical is a missionary component of a software, which if it fails, it will harm the human or the environment in general.
Okay, so but in the end, the analysis was mainly based on the keywords and your understanding and a manual inspection of the content. I was hoping that it could have been possible to identify also some these specific characteristics within the source code itself, but I guess this is kind of hard.
Yeah. It was very difficult to recognize the which exact components in some projects, because there was a lack of documentation to understand when you go through a whole repository to understand which specific classes or files were, for example, only for braking systems.
Elisabetta, what you suggested is the next phase, to actually look at the source code to understand if and whether it is different than other non-safety critical systems.
Yeah, that would be really great. I mean, having something that could, given a piece of software, could allow you to understand whether you can classify it as safety critical. Okay, do you have other questions from the audience?
I just have one quick question. I noticed in the slide that you just had up, you didn't mention testing, because of course, a specific testing regime that a piece of software goes through can be very domain specific. For example, the space industry has a very specific internal set of testing infrastructure and methodologies. So is there a plan to extend in that direction as well?
You mean, if I understand correctly, to extend the query keywords to testing? Okay, yes, I didn't consider that. It's a very good idea. Yes, we should probably extend this. Thank you.
Okay.
Okay, thank you very much, Rafaila, for the talk. So we move on. We are late, but maybe we can spend then a few more minutes for wrapping up and discussion. So our last speaker is Jaime Delgado. I do hope I have pronounced your name correctly. If not, apologies. And the title of the paper is Approaches to the Integration of Trust and Fair Principles. So please, Jaime, I hope you can share your screen.
Let me share my screen.
Yes, we see it.
Yes. Okay, so you see my full screen, okay? Thank you for the introduction. Yes, I am Jaime Delgado from the Universitat Politécnica de Catalunya in Barcelona. And the work I'm going to present has been done in collaboration with my colleagues from Institute of Biomedicine of Sevilla, also in Spain. So what we are working on is on approaches to integration of trust and fair principles. So this presentation is not fully situated in the context of open source, but very much related to it. And this is something that we wanted to present here. So, sorry. Okay, so the content of my presentation, we try to be quick and to fit to my 10 minutes. So is covering the two parts, the fair part and the trust part. So I will deal with the fair principles, the idea of the verification, the Fair for Health project, in which we have done this work, we are doing this work. And then I will move to the idea of the trust principles and finalize with the relationship between the trust principles and verification, and indirectly to the idea of the open source. So very quickly, the idea of FAIR, if you are not familiar with, is trying to make the data findable, accessible, interoperable, and reusable. So with this in mind, we are improving the way of sharing data that could be done in different contexts. We are working more in the context of e-health information. However, this could apply to other areas. So the more findable the information is, the more accessible, the more interoperable, the more reusable, then will be easier to share. So we need to put efforts on trying to achieve this. It's not evident. Conceptually may be clear, but we need to do some work to achieve that. This is something that is going on elsewhere. This was initiated by GoFair, and also there is a lot of work on the Research Data Alliance, the Force 11 group, and the Fair for Health projects in which we are working. But there is a lot of work currently on the idea of improving FAIR, of achieving FAIR on data. So the point is, we could define some steps, a kind of workflow in which we achieve these 4 elements, the F, the A, the I, and the R. So this is the verification steps, the verification process. There is not a specific standard on how this is to be done, but there are some general ideas and some common approaches on that. In Fair for Health, we have tried to combine different initiatives, and we are adapting the verification workflow steps to these 9 ones. So the idea is that when you want to have information to be fair, you need first the raw data analysis phase, then you need the data curation and validation. Then you have to start with the security aspects for data identification, anonymization, then to structure the data with semantic modeling, making data linkable, again, on security, the license attribution, and then to have more facilities on the data access, to have license attribute, the data versioning, to aggregate metadata, and at the end, to archive the information. So once you follow all these steps, of course, you do not need to do strictly all of them, but this is the idea of the 9 steps you could follow in order to make data fair. In Fair for Health, we are working on this. We are developing some tools, and then this is where the open source aspects enter, because the idea is to develop all this verification process in an open source software environment. For example, there is a tool for data curation, and there is another tool on data privacy. If I go back to the list of the steps for the verification, we could see that data curation is an important step, and then privacy is distributed in different other steps. So the data curation helps to work in a common view, in a common standard on the data. Basically, we are focusing on HL7 FHIR, and also some terminology, health terminology aspects. Then for the data privacy, again, we are focusing on FHIR, and then the idea is to identify the information that is more sensitive, and then to develop some tool sets for the different steps, the ones I mentioned before, the data identification, anonymization, and so on. This is just a simple schema of what are the agents and the platforms on which the Fair for Health project is working on. So this is the fair aspect. If we move to the trust aspects, in the same way as we had these 4 fair principles, we have 5 trust principles. We are playing with the first characters of the 5 characters of the word trust. We can develop different concepts. Again, there are different initiatives on this. For example, the Ethics project defined the trust principle as transparency, reciprocity, universality, security, and higher data use. Then the Research Data Alliance tried to put something more formal and more specific on these trust principles, and then they slightly changed the meaning of the concepts to transparency, responsibility, user community, sustainability, and technology. And then they go further and provide some data, some specific concepts associated to these principles that I could summarize here. So transparency has implications on data provenance and data curation, responsibility on data quality, user community on engagement and responsiveness, technology on reliability, flexibility, scalability, and so on. So they are going further in trying to be as much formal as possible in the definition of these trust principles. But nevertheless, this is another approach. And in fact, we are trying to combine the different approaches to these trust principles, and then we have our own definition on trust in which we combine the previous ones, and we could say something like this. So we have transparency as, again, responsibility combined with reciprocity, universality and standards, that is very important to be specific, the sustainability and the technology. Standards, in fact, are covered in all the aspects, so but before they were not explicitly identified. Then the next step was, okay, we have these trust principles, we have the verification steps, so we have these 5 elements here, the 9 elements here, so let's try to relate them. And then the next step will be, okay, we are implementing all these steps, we are implementing tools for these steps with these objectives of trust, then this will at the end apply to the open source software that will be behind this concept. So for example, and this is just a very first attempt, but we still need to work further on this, the transparency related to the raw data analysis and the archiving. The responsibility and reciprocity could be related also to raw data analysis, but also to the license attribution on the metadata aggregation. The same could be done for universally standards, applying to data curation, the data identification, data linkability, data versioning, and we could do the same for sustainability and also for technology. So at the end, we have a list of mappings between the trust principles and the verification process. So this is where we are, and what we want to do. Well, we have we continue focusing on the FAIR principles with the objective of sharing of data. We are developing tools for this verification process in the FAIR for Health project, in which open source software is one objective. And therefore, the trustworthiness is also for data and software. Although what I have presented here is just on the data. So then this is the mapping I've just presented for between trust principles and the verification process. And then behind this, the objective is to develop a methodology to follow the trust and the FAIR principles when developing the open source software for providing access to health data. So behind all this background, the idea is to have a methodology in which trust and FAIR are working together. In relation to this, we will continue to develop this further, as I mentioned before, and also in parallel, we also consider other related methodologies, as for example, adding security and privacy to FAIR-oriented systems and the associated steps. Okay, thank you very much for the attention.
Thank you very much for the presentation. Do we have some time for a quick question? Do you have questions from the audience? There is a question by John, who is that is more maybe more for Frank. So I would postpone this question. If there is any other question specifically on what Jaime has been presented. Yeah, David.
Yeah. Okay. So in terms of your utilization and exploitation, particularly of FAIR, is there anything that you would pass back to the developers of that process stroke standard and also for trust, that having experienced and utilized it, particularly in a domain that may be brushing the edge of what they intended, that you think could be done to improve it?
Well, I'm not sure if I completely got your question, but the idea is that we have different concepts that we are applying. The FAIR is our main objectives in the area of health information. So for this, we need this verification process. For this, we need to develop a software, and then the trust that is behind this should apply to all these steps.
Yeah.
So the verification, to the development of the tools, and at the end, this indirectly will apply to the open source software. And of course, all these things should follow standards as much as possible, even though we need to be open in the different approaches. That, of course, if we are able to standardize the steps, we will have best chances to achieve interoperability and at the end to have mechanisms to measure and to improve the trust.
Okay.
Thank you. So actually, I have another question. You mentioned, of course, that you have been focusing on data, but you plan to apply the approach on open source software. Did you have the opportunity already to think at how this your approach could change when considering software as opposed to open data in this analysis?
Yeah, that's a good question, because we still need to go on that step. So we might find some difficulties on this. That's true. So the first point is just on the general approach, on the development of the specific tools, and then once we have identified the approach to developing the different tools, then we could try to have something more generic on the open source concept. But we're still far from having real results. We are for the moment more focusing on the data and then to the software afterwards.
Great, thank you. There is a hint by Roberto in the chat.
Yeah, okay, thank you very much. Yeah.
So maybe we can go very quickly to the question John posed to Frank, that is in the chat. Frank, you want to, John, you want to elaborate on the question?
Well, that apparently occurred to me because I know that Frank said they're involved, for example, in Gaia X, and listening to Jaime talk, I am quite sure that he can't sit there. I doubt that they're just sitting there as neutral providers, plain vanilla, without any kind of partnership in helping them towards their goals. So I'd be curious to hear more about, for maybe using the example of Gaia X, how Nextcloud does more than just provide memory.
So I'm really sorry, but which questions are you referring to? That just lost an overview a little bit. I'm sorry.
Okay. Well, we just heard them talk about an initiative for promoting fair data, for example, and trust and things like this. And I'm thinking of you as a provider of cloud services, and I find it hard to believe that you just provide data storage, that you probably act as a kind of a partner, also helping them develop value-added services that help towards this. And I'd be curious to hear more how you see yourself positioned in such initiatives.
Yeah, so sorry that I didn't mention that in my presentation. It was just not enough time. So we are actually a bit surprisingly positioned, I think, because we have cloud in the name, but we're actually not a cloud company. We're actually a software company. So we build the software and we give away the software as open source, and we give the software to our customers and partners, and they run the service, which means we don't have any service, we don't have any infrastructure, we don't have any user accounts, we don't have any data or nothing. We just build the software and we basically help everybody else, like from small home users up to like big corporations. I mean, the German government is a customer, the French government, European Commission, German Telecom, Red Cross, Siemens, and many other organizations are customers. They're running themselves or at cloud providers they trust. But we as Nextcloud, we only build the software. This is by principle, because we don't want to, we don't want to become another central place for data and user accounts. But to answer the question, yeah, I'm actually happy to look into ways to work together, because I completely agree with the principles. So happy to work together, but we are not a cloud hoster. We are just doing the software.
Thanks, I understand.
Yeah.
I think there was a question by Roberto.
Yes, actually, it was more of a comment. I mean, going in the direction of what Carl said here. The trust principles that are typically principles that are applied to repositories for data. There is a full certification process in the data repository if you look in that space, which is not our typical area of expertise. The fact that OwnCloud actually provides tools that allow somebody to run a cloud on-premise is a beautiful way to actually allow data providers or data archives, repositories to satisfy these trust principles, because they can have open source software which is properly installed, and they need to have then certified tons of principles like backup properly done, etc., data curation. Yeah. So I believe there is value in OwnCloud and to help doing this, but I fully agree it is not their main business.
Thank you, Roberto. So, David, you have a question?
Yeah, I was going to go back to Frank, actually. So I was surprised that Nextcloud doesn't at least have some instances that it enables or manages that people can at least try the product out on a platform, because that's quite a high threshold. If there's not a a really quick, easy to utilize, but sort of available version of this of the tool.
So there are two things. I mean, of course, we have a demo server. You can go to our demo server and click around, but it's only for testing. All data is removed, I believe, once an hour. So it's really just for testing. And then, if you want to have a hosted Nextcloud, this of course exists. And on our website, we list over 100 partners who offer hosted Nextclouds. So we actually want to empower all these small service providers and companies, from big to small, to host, to provide the service, and we provide the software for that. And on our website, you can choose between all of them, and you find the right one you like. But we don't want to run an official one. I think this is goes against our principle of decentralization.
Okay.
So thank you. I have a question for, actually I have a question for Frank and another one for Roberto that I could not pose before. If I may, my question for Frank is, you mentioned, you've been talking about the importance of open standards and the possibility of having multiple implementations, of course, that against these open standards. And certainly this is very useful because it certainly avoid situations in which customers are locked into a specific implementation. On the other hand, I've got also the impression that whenever the standardization process comes into place, then I mean, the development tends to slow down, and sometimes companies don't like standards, at least software companies, as opposed, for instance, to telecommunication companies that are much more conservative, don't like standards exactly because it is the process slows down everything. So I was wondering, what do you think about this? And maybe the other question is, isn't that the tendency of Europeans to go more toward the standards be in some way counterproductive if we compare this with the attitude of the US companies to go in the market and to offer their products?
Yeah, that's a very good question. So first of all, I completely agree with you with the pain that standardization can sometimes be takes a long time and slow down innovation. I'm personally was involved in some standardization projects, the Activity Pub standard and others. So yeah, once this process happens, it takes, I don't know, between 1 and multiple years, and until then it's really hard to do innovation on top. So that's definitely a challenge. So I'm not an economist, I'm not an expert in that, but the way I see it is that usually you have like one player which is very innovative and they create a new thing, they create a new tool or platform or API or something, and I think they are and they have all the right to shape this as they want, and they have their business model, and that's all fine. And once it becomes more mainstream, then the public interest kicks in and said, okay, maybe we don't want to have a monopoly, and maybe we want to have an open market of different implementations. Maybe it's a good thing that we have, as I said earlier, different car manufacturers, different phone manufacturers, and different whatever. That's, I think, beneficial for society. And in this case, the government or the society have to make sure that there is open competition. So as I said, that you can like fuel up every car on every fuel station, or that you can charge every phone with every charger, something like that, to create like this equal playing field where basically competition is possible. And then I think this is at the time where open standards come in. But again, I'm not really sure am I really qualified. This is just my personal opinion here.
Matthias, do you have any?
I don't have a dissenting view to Frank, but I wanted to add that in Germany here, I participated in a conversation where it also was about open source and open standards. And I think the telecommunication industry is a rather bad example for what we want to achieve, because very often standards are used to exclude people. And I think what we are talking about here is standards who are helping to include as many players as possible. And so a top-down standardization is not helpful, but a standardization on what a living standardization. And I think this is also where the US probably are ahead of us, because they just deliver standardization by just doing something instead of waiting for a standardization committee to standardize it. And you have seen that, to give an example, probably Frank can is even deeper into that, in the next versions of HTTP standard, right? Or HTML. The browser vendors and some big players just tried it out, and then the standardization for everybody to follow was done afterwards, up to the fact that some people had removed then add-ons to the old standard from their browsers, for example. So I think a top-down standard doesn't work. A living standard where multiple players agree on to go forward with it, that's probably the better approach. But I'm open to be for someone to disagree. Thank you.
Thank you very much. I don't know if David or Roberto.
Yeah, well, so I think an interesting one there was Frank's comment that standards take time. Standards can be done quickly. They just need people to be really organized. You know, so I was a board member for a standards development organization, and we recognized that there was a couple of those standards that really could be done and pushed out quickly by getting everyone organized. But I want to also sort of think about some of the earlier examples that Frank gave, you know, and, you know, I think a tricky one when it comes to the cloud is actually one of our greatest problems. So you mentioned surveillance capitalism. I think a greater problem is that there's many people in society who want stuff for free. If you go and, I know many providers of tech, sort of online apps and things like that, who will supply you with the version that comes without adverts for the equivalent of €2 or €3 a month, which actually, when you think of the amount of energy that is used to store your bit, is probably actually quite a good deal. But people don't pay it because it involves paying for something. So I think one of the problems is a societal one, more about the fact that we won't pay for stuff, which therefore somebody somewhere has to come up with a different business model. And I think I'd go with the roads example and say, interestingly enough, there are standards and they're very rigorously applied because, for example, in the UK, I can build my own car, quite literally. I can build completely my own car and I can get an exemption so it doesn't have to go through any sort of crash testing or anything like that. And that would be illegal in Germany. Because I know that there's a very burgeoning business in the UK of exporting what are known as kit cars from the UK once they're registered from the UK into mainland Europe for people that want interesting and different vehicles. So I think there's certain standards, but there's essentially then sort of requirements over the top that I think are sort of be above and beyond standards that are applied. And I think that's quite an interesting sort of issue where we talk about software and how, software and services and how they're made available.
Thank you very much, Dave.
Yeah, and I agree with David said about the challenges of free services. I mean, this is all like connected to the whole surveillance capitalism discussion that we give away things for free that actually cost money, but they're giving away for free, and people pay in other ways. And that's of course a challenge. Yeah. It's something, I mean, I mentioned that I was involved in open source for 20 years or over 20 years now. I'm old. And forever, like with Linux, basically fighting HPUX and all the proprietary Unix systems, or when in the early 2000s, where everybody's hoping for the year of the Linux desktop or LibreOffice as an alternative for the Microsoft Office and Firefox and all these other things. What we always had is we were able to give people the freedom, but we also had the cost side the cost benefit on our side. I mean, always open source was always cheaper. Okay, you get the freedom, but you also get a cost benefit. Nowadays, open source is more expensive than proprietary. That's quite interesting, because if you look at Nextcloud, for example, you can download the software for free from our website, but you need to host it somewhere. You need a server and you need storage and you need a sysadmin to operate it. And this all costs money. While if you just go to Dropbox or Google, you don't need that. So proprietary software is nowadays cheaper than open source software, at least in the cloud space. And that's an interesting challenge.
Roberto has posted in the chat a link to a paper that is
yeah, maybe I may comment on that. I mean, this
yes.
Last year I saw a presentation by Mirko Böhm, who is now he was involved in open source for a long time. Now he is working for Daimler in the new hospital there. And he had a very nice analysis of the relationships and difference between the standard setting methods that you have via standard setting organization and what happens in the open source space. You may agree or disagree, but this is a well-researched paper, so I do suggest people interested in having a look into that. Then to react to what Frank actually was saying, I wouldn't say that proprietary software is cheaper than open source today, because the example you give is more that, I mean, online services which have a business model hidden from your eyes are cheaper than online services where actually you see the cost and you pay for the cost. The difference is what you are giving away behind the scene. Then if it is open or closed, I'm not sure this is a real relevant difference. You can run a business online by giving things away, hosting an open source solution. And then your competitor will need to do the same if they want to sell it for free. Okay, so if you have a business, I heard that most of the big proprietary cloud platform actually run tons of open source on their side. So it's not a matter of open or closed, it's the business model you have to setting around, which is an interesting discussion. I do not know if you agree, Frank. I mean,
yeah, maybe I can add two things. First of all, you're of course completely right. I intentionally blurred together the cost of the software with the cost of the service, which is not the same. Of course, you're right. This was a simplification on my side. But from an end user perspective, it's of course something like Nextcloud. You can't use it when it's sitting on your local hard disk, right? You need to run it somewhere. So it's only useful as a service. So in our example, it is, it is similar. But of course, precisely, you're right. On the other hand, this is an argument like AWS or Microsoft using lots of open source software. That's actually something that's an argument that really annoys me, because this is something that's used in marketing a lot. And it's true, of course, they're building on top of open source as everybody else is doing, sure. But the thing is, in my presentation, I talked about the 4 freedoms, and it doesn't help if Azure is running on top of the Linux kernel, when there is always a layer above which is not open, and this is enough to have the vendor login. Right? Of course, everybody's using open source, but you only have the full freedom once the full stack is open. And what they're all doing is they use 90% of the nice free software stuff, building 10% on top of it, and then have a proprietary service.
I fully agree, Frank. I have seen this for decades. I think I'm older than you, and I hate it. Fully agree with you with this kind of situation. I was just making a point about the business model.
Hi, can I just join the discussion? I'm really happy to see Elisabetta organizing such a beautiful and interesting event with a lot of interesting talks. So what I wanted to say is that, so we work on 2 projects on decentralization, and one of them is a next generation internet project onto chain. And I wanted to say, because of these standards, that we are kind of pushed by the Commission to contribute under, sort of contributes to standards all the time. And we know that in software and in IT, standards are actually too fast. I mean, de facto and de jure standards. And in the end, everything happens before standardization, actual standardization. But from the viewpoint of what is happening in the area of decentralization, for example, this on-to-chain project that we run, we come to more and more to the conclusion that blockchains are actually going to make a huge transformation also in all areas of human life, I would say. This is my personal opinion. And particularly also in the area of software, which means that one could imagine that standards would be evolving in the future, even with the possibility of blockchains, so that it's possible to share, because blockchains are actually sharing their shared databases. And in the future, one could imagine all sorts of other knowledge being shared via blockchains, so that one could imagine that standards and human, let me say, not only in the area of software, but in all other areas, it would be possible to imagine ecosystems based on common denominators, which are standards, of course, that would be able to, let's say, happen. So for me, in the very near future, all this type of activities that we do related to standards and to other activities, I would say, would be transformed by means of blockchains in some way or another. I cannot say exactly, pinpoint the way how this will happen, but I'm quite confident that this will happen. So this is just a comment from my side. Thank you. I will paste the link on the 2 projects we work on.
Thank you very much. So we are essentially, we passed 6 o'clock, so maybe we need to close. I have a very quick question for Roberto. If you can take it, Roberto, otherwise
Sure.
I understand. The question is related to the scalability of software heritage. Of course, thinking at archiving existing software, I can imagine that the size of the dataset can only increase. And so I am wondering how you plan to handle this situation on the long term.
That's a very interesting question. So I do suggest that people go to www.softwareheritage.org/publication. You will see a bunch of publications. There is one from last year published in ESEM, where you will see the real estimate of the growth of the original content we see in the archive. And that was an analysis we done with Guillaume Rousseau and Stefano Zacchiroli. And you will see that the original content doubles every 2 years and has been doubling every 2 years constantly since 20 years ago. So there is a real exponential going on there. So the challenge you are mentioning is very real. And we have already seen it. I mean, since we started 5 years ago to now, you see how it explodes. At the same time, we use this spatial data structure that allows us to care only about the new original content, not about the forks, the copies, etc., because we get rid of them. And to track this exponential, for the moment, we are still lucky because every 2 years or so, the cost of memory is divided by 2. So up to now, we can hope follow up with constant cost. And in any case, the amount of data we are storing is massively smaller than what you see in huge data center for videos or for experiments in physics, etc. So that's not a big issue. What is a big issue is how do you scale up on that infrastructure the functionalities you want to provide to other people. Traceability, provenance, search, indexing, bug fixing, bug detection, all this kind of thing. And this is a challenge for our community. How can we use or build or adapt all the beautiful tools that the software engineering community has developed, experimented, designed, imagined, to work on such a huge amount of content, designed and structured in a way which is very, very different from what you find in traditional archive. I mean, using these gigantic query languages on the graph, which are efficient. There are tons of things that are coming out. I mean, you will see in the publication some technology from the web. I mean, how you compress the graph of the web. How can Google or Microsoft have a search engine that works when you have hundreds of billions of nodes, etc. You use technology which is actually open source and designed by colleagues of ours. They just don't have the large infrastructure used by these companies. So when we use it, actually Stefano with Sebastiano Vigna worked on this kind of thing, and we have an in-memory representation of all this Merkle graph that allows beautiful things. All this is just experimental, but then you need to plug onto this all the experimental done in software engineering and in other areas. And this is where I believe there is a challenge. There are opportunities for our community to actually work together and propose and create a European research infrastructure around software where we can provide this building block, which is software, and where the community, our community and a broader community can use it as a research tool, the same way friends of mine use a telescope or other people use a particle accelerator. Just use it to do experiment, to develop tools, and then if there are tools which work well, we will just put them in production, and there will be new building blocks on top of which other people could build. You see the kind of vision, Elizabeth. I would be delighted to see more people being intrigued or sharing this vision and try to work it together into making it a reality.
So to me, Roberto, this sounds like, and you know, you need to become a user on the European Open Science Cloud.
Absolutely. Well, European Open Science Cloud is not a cloud, you know. It's not an infrastructure.
Yeah, well, actually, yes, because unfortunately they didn't follow through with what was the precursor in the EGI federated cloud, which would actually have enabled a unified European-wide infrastructure.
But we are involved with the EOSC. I mean, you know, I'm involved with this kind of people. Unfortunately, there is not enough people from our community involved in that particular effort. It is very focused on data repositories, on fair data, and these things. Software is kind of poor child in there. We tried to bring it on board. There is now a working group on software, which probably will be created in the
You should talk to EGI.eu about their federated cloud, which does still exist as which is for research and would be a suitable place to do this. But one of the questions so I have a very simple question. So you mentioned, of course, that as it stands at the moment, the amount of data in the software code and everything is small and everything else. But so I suppose my facile question would be, well, at what point does it become big, and at what point do you have to start thinking about the amount of energy that you're consuming to actually store it and this sort of thing? Because we have to all justify what we're doing with a net zero hat on these days.
Absolutely.
So
very good point. Very good point. But let me tell you something. I do not know if this is a. No, I do not have time to tell you the full anecdote. So with this, we will need to wait for a real beer, not for a virtual beer like this. You know, there is no such a thing like a virtual beer, unfortunately. But the point, if you look around, for example, in Europe, in the different departments, etc., there is an incredible amount of replication, data centers and computing machines and supercomputers. Maybe you can justify supercomputers, but can you really justify that every single university in Germany or in the UK, I do not know, have their own institutional repository for open access, etc.? That means backups and sysadmins and machines, etc. Why not having a shared infrastructure? So the approach in software heritage is actually takes into account carbon impact. Okay, so instead of asking everybody to set up a data center with a backup and refrigeration and all the mess and people working on top of this, to store only the small amount of software they have in their little organization, and I can tell you, there are many people doing this right away. What I do propose is we have one shared infrastructure, one. So you have one backup, one data center, one refrigeration, etc. With replication, we have mirrors as needed to make sure you don't lose data, but not more. So that is the most efficient way of actually keeping data. It is much less expensive than what we are spending today by maintaining these tons of replicated things around the world by just keeping them a couple of hundred software projects or some tens of thousands of papers. So we should be modular in the design of the infrastructure we build, not just locally, but globally. So the principles behind software heritage try to go in that direction. So propose a global shared infrastructure that will be more economical than a gazillion of little things that are around. So I'm not sure this answered fully what you wanted me to say, but
no,
I hope you appreciate the point.
You could partner with Amazon or someone. Sorry, I couldn't resist.
We have a partnership with Azure. We have a partnership with Amazon that actually store a copy just for reliability. I would be delighted. I mean, little hint to Frank and other people. We'd be delighted to have a partnership with a European cloud just for replication. But my really belief is that what we can do is to work in the research area. So you see the partnership we have with IDEA is, I believe, more interesting, because that way we can provide also a tool for doing research on top of this data, and it is in research space.
Yeah.
And up to now, at my knowledge, we never really succeeded as the computing community to actually bring forward large projects where you look for infrastructure. So typically this kind of infrastructure, GI, etc., this comes from physics, right? Not from computer science. So I wonder if this is not an opportunity for us all as a community to bring forward a common joint project where we propose to the Commission to fund a real common effort on a research infrastructure for computing, for software studies that we do not have.
We could propose and see what they say.
Yes, absolutely. Sorry, I tend to speak too much, Elisabetta, so feel free to cut me whenever you want.
No, actually, very, very interesting discussion. We are really out of time, but really thank you all for the discussion and for the participation. Is there any other question or point to be discussed? If not, we will try anyhow to write down a summary of this discussion and to include it in the proceedings of the workshop. And before introducing this discussion in the proceeding, we will send it to you, so that the summary to you, so that you can check whether we captured at least the most important parts of the discussion. That was very, very interesting. So thank you very much.
Thanks a lot.
Everyone, thank you, Roberto. Thank you, Frank. Thank you, all the other speakers and the participants as well.